Let's talk about something we all think we know, the speed of light. You know, that ultimate cosmic speed limit. But what if I told you that name, the speed of light, is actually pretty misleading? And that the real story is so much bigger, so much more fundamental to reality itself. Okay, to kick things off, let's start with the classic. Picture this. You're on a super fast rocket cruising along at, say, half the speed of light. You point a flashlight forward and switch it on. Now, basic logic, right? Your speed plus the light speed should equal a new, faster speed. It just makes sense. But the universe has other plans. The answer to that question is a clear, definitive, hard no. In fact, if you measured the light coming from that flashlight, you'd find it's traveling at the exact same speed of light as always. It's weird. And the reason this happens isn't just some quirky little rule. It's a clue that points to a truth about the very fabric of space and time that is way more incredible than you might think. So, if it really is the ultimate speed limit, why doesn't our simple addition trick work? Well, it turns out the universe just doesn't do math that way. Yeah, our simple speed 1 plus speed 2 intuition is, well, wrong. The universe actually uses this special formula to add speeds together. Now, don't worry, you don't need to memorize it. Just look at that bottom part. As your speeds get closer and closer to c, the denominator gets bigger, which actually slows the whole result down. It's designed to make sure you can never ever exceed c. In fact, if you plug c itself into the formula, the math just spits c right back out. It's a cosmic rule, hard-coded into the math of the universe. So how on earth does the universe enforce this? This is where it gets really mind-bending. The universe doesn't treat space and time as fixed things. To us, a second is a second. A meter is a meter. But to the universe, they're flexible. Space-time itself will literally warp, stretch, and shrink just to make absolutely sure that one thing, and one thing only, stays the same for every single person, no matter how fast they're going, the speed we call c. And this brings us right to the heart of this whole thing. We've been calling c by the wrong name this entire time. I absolutely love this quote from a Reddit discussion on this topic because it just nails it. The constant c isn't really about light. Light just happens to be the most famous thing that travels at this speed, basically because it has no mass. The real name, the much better name for this constant, is the speed of causality. So what is the speed of causality? Think of it as the universe's ultimate speed limit for anything to happen. It's the fastest that any information can travel. It's the fastest a force, like gravity, can be felt across space. It is the absolute maximum speed at which a cause can create an effect, period. This chart perfectly captures the huge shift in thinking Einstein gave us. We live our lives feeling like time and space are the fixed, constant background, but reality is the other way around. The one true, unbreakable constant is the speed of causality. And it's space and time that are the flexible things that have to bend and warp to protect that one constant. Okay, so this unbreakable speed of causality leads to some really famous results, including probably the most iconic equation in all of human history. You know it, you've seen it everywhere. E equals mc squared. It beautifully links energy and mass. But what most of us don't realize is that this is the simplified pop culture version of the equation. Yep, it's not the whole story. The famous version you see on t-shirts, it actually only works for objects that are sitting perfectly still with zero momentum. Here it is, the full energy-momentum relation. It might look a little more intimidating, but all it's doing is adding one more piece to the puzzle, momentum, which is labeled with a P. This part represents the energy an object has from its motion. And this is where it gets really cool. Think about a particle of light, a photon. Its mass, m, is 0. So that whole mc squared part of the equation just vanishes. What are you left with? E equals pc. Now think about what that means. For a massless particle to even exist, to have any energy or momentum at all, it must travel at speed c. It literally has no choice. It's the only way it can be. So why is this speed of causality so absolute? I mean, what would actually happen if we could break it? Well, the short answer is, you'd break reality itself. Let's run a little thought experiment to see why. We've got Alice on Earth and her friend Bob, who's flying away from her in a rocket at nearly the speed of light. Now remember that weirdness with space-time? One of the side effects is something called time dilation. The faster Bob moves, the slower his clock seems to tick from Alice's point of view. Okay, stick with me here because it's a trip. At exactly 4 p.m. her time, Alice sends an instantaneous faster-than-light message to Bob. Because of that time dilation, when Bob gets the message, his clock only reads 2 p.m. Let's say he immediately sends a faster-than-light reply back. Now here's the paradox. Because of how relativity works, from Alice's perspective, that returning FTL signal actually travels backwards in time. It arrives back at her station at 3:59 and 59 seconds. Just think about that for a second. Alice receives a reply to her message 1 second before she even sent it. How is that possible? It's not just weird, it completely shatters the idea of cause and effect. And that is why the speed of causality has to be the absolute limit. Breaking it doesn't just mean you're going fast. It means you're breaking the logical flow of the universe. So we know that c is this reality-defining constant. But how did we even figure this out? How did we go from just seeing sunlight to being able to pin down the exact number that governs the universe?
But first, a quick practical question. Can light itself ever actually go slower than c?
And the answer is yes, but with a really important catch. When light passes through something, a medium like water or air or glass, it does slow down. That's actually why a straw in a glass of water looks bent. It's called refraction. But the constant c specifically refers to the speed of causality and of light in a perfect vacuum with nothing in the way. And that speed never, ever changes. You know, our journey to actually measure this number has been a long one. Way back in the 1600s, Galileo tried with some lanterns on hills, but light was just way too fast. The first real proof that its speed was finite actually came from looking at the moons of Jupiter. As the centuries went on, our methods got way more clever, using things like spinning gears and mirrors. And we got so good at measuring it, so incredibly precise, that in 1983, we just flipped the whole thing around. We decided to fix the value of c as a perfect, defined number, and now we use it to define what a meter is. And there it is, 299,792,458 meters per second. That's not just how fast a photon zips through a vacuum. It's the speed of causality. It is the tick rate of reality itself. It's the fundamental rule that shapes your experience of space and time. So the next time you hear someone talk about the speed of light, you'll know the secret. It's really the speed of your reality.